All right, now we're into 6.2, solving quadratic equations. So how can factoring help you solve a quadratic equation? So by solving, what they mean is finding the x's, so finding the x-intercepts. So if we took our graph and we had some sort of parabola, when we talk about solving it, we are talking about finding the x-intercepts. So in our equation, basically we are making y 0. So we are figuring out what our x's are to make in this equation in order to figure out what our x-intercepts are. So we've already kind of looked at it when we talked about x minus r, x minus s, but now we're going to get more complicated. So if the product of two numbers is 0, what must be true about one or both of those numbers? So product. So again, looking at what this words mean. So if we've got two numbers and their product multiplying are 0, what must be true about the value of A or the value of B or both? So what we need to know is, how are we going to multiply two things together to make a 0? So the only way to do that, and pause here and think about it for a few seconds, but the only way to do that is either A equals 0, B equals 0, or both equals 0. The only way to multiply two things together and get a 0 is if one or both of them are 0. So hopefully we realize that that's true. So number 3, how does step 1 and 2 relate to solving the equation x minus 3, x plus 5 equals 0? So if we make this an A and this a B equaling 0, and we know that either A equals 0, B equals 0, or both, which in this case they both can equal 0 because x is going to be two different things, we're going to have two different answers. So we can't have both because we're going to have two different answers for x. So if we want them to, for this to be true, for the equation to equal 0, A has to equal 0 or B has to equal 0. So what we do is we say either A has to equal 0 or B has to equal 0. So now we have two answers for x. So x is either going to equal 3, because if we move, if we move 3 to the other side, we end up changing its sign, and it becomes from -3 to +3. Or we do the same as the other side. X can equal -5. So that's going back to our x minus r, x minus s, where r and s are the x-intercepts. So that is, in this case, we've got -5, 0, and 3, 0 as our two intercepts. Not exactly drawn there, but was just doing it roughly. So we've got two possible answers for x. But if either one of those are true, then we've got our answers. So they're both the answers of x minus 3, x plus 5 equals 0. So when x equals 3, that's true. Because if we check that, x equals 3, x minus 3, x plus 5 equals 0. If we make x equal to 3, 3 minus 3, 3 plus 5 equals 0. We end up with 0 times 8 equals 0, and we end up with 0 equals 0. So we've got check there. We can also check x equals 5. Now we've got 5 minus 3. Minus 5. Minus 5 minus 3, minus 5 plus 5 equals 0. We end up with negative 8 times 0 equals 0, or 0 equals 0. So we are correct in those two answers. So how can we factor to help us solve a quadratic equation? We are going to end up putting our equations into this form so that we can figure out which one or what our zeros are going to be, since this is our x-intercept formula. So if a times b equals 0, we know that a equals 0 or b equals 0 or both. In these cases, they can't both equal 0 because they're two different x's. So we solved that already. So we've got x can equal 3 or x equals negative 5. Explain why your solution causes the left side of the equation to equal 0. So we could explain that out in words, but because either one of those numbers creates a 0 and we're multiplying by that 0, it's going to end up being 0 equals 0. So using this method, we're going to solve each equation. So let's start with A. So basically, their steps is you're going to put, if it's not already in our RS formula, or our zeros or roots equation, I think they call it the roots equation. We start using the word roots later on. We need to split it up. Once we've got it into two brackets, we split them each up. So if we call this A and this B, we split them up and make A equals 0 and B equals 0. So we take the first one, and we can drop those brackets. Make it equal to 0. Make the second one equal to 0. And just manipulate our equations. If you're still having problems manipulating your equations, you need to go right back to some of the work we did at the very beginning of the year. So I'm doing that by, I've got a plus 2 on either side, so I'm subtracting 2 on either side. Or you can think of it as I've taken a plus 9, it jumps over the equal sign and changes its sign. Two ways to think about that. So now I've got x minus 2 and x minus 9. And if we throw those back into the equation to check, we've got minus 2 plus 2. These are easy ones, so you can probably see this, but on a test or a quiz, you'll be expected to check. 0 times 7, 0 equals 0. Same on with the negative 9. Negative 9 plus 2 minus 9 plus 9 equals 0. And again, we've got, notice that we end up with the same numbers all the time, a minus 7 and a plus 7. This is not coincidence. Now, B becomes a little more difficult because we have coefficients in front of our x's. But same process. We take A, make it worth 0. We do our B, make it worth 0. So the two brackets, split them up. Make one equal to 0 and make the other equal to 0 and do them separately. You can drop the brackets right away or you can just keep them in for a second. So now that 5 jumps over the equal sign, becomes a minus. And then we've got one more step. So that 2 is multiplying by x on the left-hand side. So to get rid of it, either it jumps over and becomes a division, or we divide both sides by that 2. Remember that the sign doesn't change when we're multiplying and dividing. So multiplying and dividing are opposites, adding and subtracting are opposites. There's some people that still try and change the sign when you're dividing, and we don't do that. So x equals -5 divided by 2. Back to blue. Again, 3x, that -4 jumps over and becomes a +4. Or we add 4 to both sides to get rid of it. Two ways to think about it. We're multiplying by x on the one side, or multiplying by 3 on one side, so we need to divide by 3 on both sides to get rid of it. And x equals 4/3. So now we've got two different answers. Let's erase and give ourselves a little bit more room to do this second check. So we want to check this. So I want to check -5/2. So again, I just put -5/2 into any spot that previously had an x. +5, 3 times -5/2 minus 4, all equaling 0. So now I have two ways to think about this one. I can either cancel out the two 2's because I'm cross multiplying, or I can think of that 2 as being 2/1, or I am going to think about it either way as 2/1. We're multiplying by fractions. Again, if you're still stuck on your fractions, you need to go back to some of the worksheets I put out at the beginning of the year. So that 2 is the same as saying 2/1. So I've got 2/1 times -5/2. I can this out. One thing I can do is to cross cancel. Take out that 2, take out that 2, they each become a 1. And we end up with -5/1, which is -5. Or, which I think most of you are going to end up doing it this way, is figuring it out as multiplying the two top numbers together, -10, multiply the two bottom numbers together, we get 2 plus 5. And let's keep going. I end up with, put that 3/1, and the same technique, multiply the two top numbers together, the bottom numbers together. Our numerators become -15, our denominators become, and -4. Again, our -10 divided by 2 is going to be -5 plus 5 when we are, and that's really our answer. Once we get that down to 0, it doesn't really matter what's in the other bracket. But we should know if we're dividing by 2, or subtracting and adding, we need to have a common denominator. So I need to have that 4 being over a 2. So I multiply the top and the bottom by 2 to become 8/2. So -15 minus 8 is -23/2 equals 0. And of course, that becomes 0, so it doesn't matter what's in the other bracket, just that we've got a 0 which will take us to 0 equals 0. So you will have to be doing checks. So you do have to work with the fractions on tests and quizzes. All right, 4/3. Again, fill in 4/3 everywhere there was an x. So again, multiplying, putting our coefficients over 1 so that we're multiplying our numerators and our denominators. We end up with 8/3 plus, and I'm going to put that 5 over 3 as well. So we're multiplying both the top and the bottom by 5, or by 3. So we get the 5 times 3 is 15. And same here where we can cancel out those 2 3s and just make it a 4. Because we are cross canceling out, or if we end up multiplying the tops and multiplying the bottoms, we end up with 12/3. And again, we end up with a positive 23 over 3, and a 4 minus 4, which equals 0. So we end up with 0 equaling 0. How is the equation x squared plus 6x plus 8 equals 0 different from the ones we've already looked at in steps 3 to 5? Describe the extra steps we're going to need. So basically, we know how to take this formula and put it into an x minus r, x minus s situation. So we just need to do that first, and then we can solve for it. So this is bringing us back to chapter 5. Let's put the 0 on that side to keep it out of the way. So pause for a second and think about, how do we do this? Going back to chapter 5, how are we going to make our standard equation look like our roots equation? So remembering our a times c equals r times s, and b equals r plus s. Remembering those hints. So we don't have an a, so really just we need two numbers that multiply to 8, which is 8, which is 6. So we need two numbers that add to 6 and multiply to 8. So we need to find factors of 8. So we can do 1 times 8. We can do 2 times 4. And of course, because we have positive numbers, we can do -1 times -8, or -2 times -4. But we know that our b term is positive, so we're not going to go there. So we know we're going to have these two, because when we add them together, they equal 6. So now we can jump straight to x plus 2, x plus 4. Now remember, when there is an a term, you can't jump straight to those blocks. You've got to pull apart that 6 and regroup and multiply. But when we only have an a term of 1, we can just simply bring it to those two. So now we've got what our two x's, or we've got broken it down to our s's. So we know what r and s are. Now we need to find our x's. So we can make both of those, separate them out, make them each equal to 0. And this is why, well, let's keep that on the right side. This is why people were asking, why is R and S negative? This is why when we solve for it, we're jumping them over the equal sign and we're getting the negative of what they are. So it's the same. We were talking about it before. We're talking about R and S. We were talking about just changing the signs because we knew that R and S were negative. Now this is the proof why, because if we make either one of them equal to 0, when we move the number over across the equal sign, it changes its sign. Oh my goodness, running out of battery. So now we've got a -2 and a -4 as our possible x's. Let's check them. Let's put them back into the original formulas. It's easy to put them back into this one and be able to see where the 0 is, but maybe we messed up by going from our step 1 to our step 2. So let's always try to go back to our original equations that we were given at the beginning from the question whenever you're doing a check, so that you are convinced that you are correct. So -2 squared, make sure we're putting the brackets in there. Remember that -2 squared, it does not equal -2 squared. This one is only squaring the 2, not the negative sign. So we need to put it, especially if you're putting something in a calculator, make sure you're putting brackets in there. That's how you're getting a wrong answer if you are using your calculator. You're not putting brackets before your exponent. So -2 squared is 4. 6 times -2 is -12 plus 8. And if we put those all together, we end up with 0 equals 0. Check -4. So again, using your brackets correctly, you've got 16 minus 24 plus 8. So right side, left side. And again, we end up with 0. So we have double checked. Both our numbers are correct. All right, example 1, solve by factoring. So we need to factor out in order to know what our two x's are. So when we've got an x squared, we can't figure it out until we've got our x's separated. So the first one, A, is just like the one we just did. So we've got ax squared plus bx plus c equals 0. And since we don't have an a term, it's just 1. We need to find two numbers that multiply to c and that add to b. So we need the factors of 14. So we've got 1 and 14, we've got 2 and 7, we're trying to get to 9. So again, we could have both of those as negatives as well, but since we have a positive 9, we are just going to add these two together and know that we're going to deal with that 2 and 7. So we can automatically change this to x plus 2, x plus 9 equals 0. That's our factoring. And then to solve it, we make the first term equal to 0, We make the second brackets equal to 0. There you go. Then we always need to do the check. Again, go back to the original formula in case you made a mistake going with your factoring. Always go back. So our left side, again, use your brackets correctly or you will make a mistake. And that equals 0. And since our right side equals 0, those are correct. And our second one, we want to check -9. Okay. So we have -9 squared. Sorry, 7. Dang it. So this is how you know you did it wrong, because I put a 9 in instead of a 7. So if I continued that check, that's how you find your mistakes. Because that would be plus 81 minus 81 plus 14, which does not equal 0. Because I screwed that up. Because this should have been a 7. So, going back, x plus 7 equals 0, x equals -7. So that's why we always do our checks, because sometimes we put in the wrong numbers even though we found the right numbers. So we did a check of -7 plus 9 times -7 plus 14. We end up with 49 minus 9 times 7 is 63 plus 14. 49 and 14 is 63 minus 63, which equals 0. So left side equals right side. Again, so that's why we do our checks, because sometimes we find the right answers and still put in the wrong answer. B. B looks tricky because we do not have a C term in there. So pause. Look at B. What can you factor out of B to separate up those x's? So we can't use our factoring that we used in A because we don't have a C term. So this one's kind of a trick question because it's easier than what you think it would be. We're just pulling out the greatest common factor. And now the greatest common factor is x. All of our numbers are unfactorable, but we can pull out that x. So now we have a different A and a different B. One possible answer for x is just 0, because x can equal, if x equals 0, then we would make this whole thing 0. We'll check that in our check. And our second in the brackets equaling 0. Again, bring that 5 across the equal sign to make it negative. And then we're dividing by the 2. So we've got two possible answers for 0. For x is 0 and negative 5 over 2. Let's check those. Check 0. So we can see that if we, as soon as we put a 0 on there, it's all going to be equal to 0 because we're multiplying two things together. If one of them 0, they're both 0. But let's always check using our original formula. Zero squared is 0, times 2 is 0, plus 5 times 0 is 0, equals 0, and we've got to check there. So as soon as we don't have a c, we automatically have one of them is going to equal 0. Why? Because we know that when we have ax squared plus bx plus c, c equals the y-intercept. So if the y-intercept is 0, then we're going to end up with a 0, 0 for our one of our points. Let's check. Negative 5 over 2. So again, go back to our original. So we need some work for our fractions here. And we are going to work with a lot of fractions. So again, if you are unclear with your fractions, it's time to look at some of the fraction help that I had at the beginning of the year, or to be Googling your own fraction work. So first we do our exponents, and we know that a divided by b all squared is the same as a squared over b squared. Those two are equal. So we're squaring the negative 5 and we're squaring the 2. So we end up with 25 over 4. And let's just leave that for now. So again, when we have a coefficient, it's just over 1, multiplying the two top numbers, multiplying the two bottom numbers. Again, I can cross cancel out some things here. Because I have a 2 and I'm just going to show you this. Because I have a 2 and a 4, I can divide both of those by 2, making my 2 into 1 and my 4 into 2, ending up with 25 over 2. I'll show you how that matches up as we move down. But if we're doing it the other way, multiplying the numerators, multiplying the denominators, we have 50 over 4. And then I've got minus 5 times plus 5. So we're changing the sign. A negative and a positive means a negative. So we've got 25 on the top and 2 on the bottom. So now 50 divided by 4, we can divide both of those by 2 to find our lowest fraction. So here we would end up with a 25 over 2 anyways, but you could have done that in one step by doing what I did at the top. So again, any number minus itself is 0, and we've got our check there. So we didn't make any mistakes on this slide. C. C looks different again because we don't have a C term on the left-hand side, but we do have numbers on the right-hand side. pause for a second and think about how you might tackle that. So what we need to do is put everything on one side and make it equal to 0. So that positive 15 jumps over the equal sign, becomes a negative 15. So it's moved over. And now we've got a question that looks exactly like our first one. So now we need factors of negative 15. So two numbers that multiply to negative 15 and to add to negative 1. So negative 15, oh, nope, because we have a 6 on this one. So let's not jump ahead. So we need two numbers that multiply to a times c, and two numbers that add to b. So a times c, 6 times 15, so we've got 90. Ooh, we're working with big numbers now. So we need to find the factors of 90. So we have 90 and 1, and sorry, not 90, negative 90. We've got negative 15 times 6, sorry. So factors of negative 90. So negative 1 and 90, or negative 90 and 1. But we know we're going to end up with a negative 1. We want a plus b to be negative 1. So we know that none of these big numbers are going to be it. So we still got 2 and 45, with 1 being negative. We've got 3 and 30. We know it's not going to be anything like that. So we want to be as close to the middle as possible. So in the middle, we've got negative 9 and 10, or 9 and negative 10. So we want to have a negative 1 as our addition. So when we add these together, we've got a 1 and a negative 1. So we know our two numbers that we want to work with are 9 and negative 10. So I didn't find all the factors of 90 because I knew it was going to be something as close to the middle as possible. So now, remembering how we do this time, rather than we can't jump straight into the brackets the way we do in A. We've got to separate those two. Remember, I like to take the negative 1 first and the positive 1 second. It makes it easier for you. Then we group them. So we've got a group 1 and a group 2. Out of our first grouping, what's our highest common factor that we can pull out? Well, we've got a 6 and a 10. So I think the highest one we can get out of there is 2. And we've got an x squared and an x, so we can take out an x. So we end up with 3x minus 5. Now that's what we're trying to get out of our next section. So that's something to think about. So I've got a 9 and a 15. The biggest I can get out of there is a 3. And again, I end up with 3x minus 5, which means I've done it correctly. So now we're grouping together. Our 3x minus 5 is like a pumpkin. You've got 2x pumpkins. I've got 3 pumpkins. And so we're going to group our pumpkins together. we've got pumpkins, and we've got 2x plus 3 pumpkins. So now we've got it in factored form. So this is our factored expression of our same equation. And we do the same thing now. Now we're dividing it into two groups, making each one equal to 0, and solving for our two x's. So x equals 5 over 3. And x equals negative 3 over 2. So if we were to graph that, we know we have a positive parabola because we don't have a negative a, but we are looking at fractions. So our 1x is 5 over 3, so 1 2/3. It would be there. And our second one is negative 2 over 3, so 1 1/2. Negative 3 over 2 and 0. And because we have a positive parabola, you're going to end up with something that looks like that. And then we could find more information about it in others. So we know, actually it'd be a much higher because, or much lower. Because we've got a negative 15 there. So those are be our two x-intercepts. So we should check those as well. Using the same process, continuing to check. Go back. I'm only going to check one of them this time, but we need to be on task doing them all. Just trying to make this video a little bit shorter. This time we can leave the 15 over there because that's going to be our new right side and our left side. So we're trying to get a 15 over here as well. So remembering that we square both the top, so 5, 25, and the bottom. So again, I can cross cancel out. My 9 and my 6 are both multiples of 3. So I can make them a 3 and a 2 and make life a lot easier for me to have 50 over 3. So we should be learning that process of cross canceling. You should have seen that in elementary school. But if you can't do that, you do it in the other step. 25 times 6 is 150. Now I need, because I'm adding and subtracting, I need a common denominator. And I know 3 is going to work because I can divide 150 by 3. I can divide 9 by 3. And here I end up with that 50 over 3 in 2 steps instead of 1. So now I have a common denominator. It's like saying that they're both over 3. 50 minus 5 is 45 over 3, which equals 15. So I've got the same on both sides. So practice by doing the same check with negative 3 over 5 or 3 over 2, and you will get this, should get the same answer. And if you don't believe me, here is the textbook answer. This is how they found them. A, B, pause and read what they're doing. So our solutions are called roots. I'm going to introduce this word, roots. So a root when they ask for the roots of the equation, what they're asking for is the x-intercepts, but that's going to be a word we're going to start using. The value of the variables that makes the equation true. So we're talking about the roots, we're finding the answers for x. So it says find the roots or solve for the roots. It just means what is x. So we use that in quadratic equations. The roots are then end up being the x-intercepts in these for these questions. And there's C, and there's the check we did not do. So we can still get 15 by putting in -3/2. Example 2, path of a stone. The path of a stone thrown into a ravine is modeled by the quadratic relation y equals -x squared plus 5x plus 84, where x represents the distance in meters traveled horizontally. So our x is meters horizontally, and our y represents height in meters. So again, we're working in meters. Above the surface of the river. So 0 is the surface of the river. So be aware of what 0 represents. Sometimes 0 might be the top of the ravine, or it might be the bottom of the water. Make sure you understand in each individual question, what does 0 mean? Or what does x mean? Or what does the x-intercept? How far does the stone travel horizontally before it hits the water? So if we want to know how far it travels horizontally, we want to know x. Newsflash, most of your questions are going to be asking you to find x. So travel horizontally in this case means find x. So we start off with our equation. How are we going to find x? If we are traveling horizontally and we want to know where it hits the water, we want to know this 0 line. So the first thing we can do, what happens when we hit the y-intercept or x-intercept? What does that make y? It makes y 0. So we're solving for x when y equals 0. So we'll hit the water when y equals 0. So we need to solve. Oh, here's a cool trick before we even get going. We don't really have to deal with this negative anymore. Because we are equal 0, we can factor out that 0 or that -1 by dividing every term by -1. So this only works when we're equal to 0. So this will only work when we're equal to 0. When we're solving for x and it's equal to 0, we can factor out that -1. So let's factor it out first. So we're going to have that -1, change all the signs inside. But now what can we do with it? So because it is multiplying with our brackets, we can divide both sides by -1 to get rid of it. What's 0 divided by anything? still 0. So we've just canceled it out because when we when we divide 0 by anything, it just becomes 0. So we've really just gotten rid of that -1. And it's okay. It's still part of it. But because we're solving for x, we don't have to deal with it this time. So that will work with if we were factoring out 2, we're factoring out 5, whatever we are factoring out, -100, we can just get rid of it once it's on by itself in front of the brackets. We divide both sides by that number. 0 divided by anything is still 0. So now we need two numbers that multiply to a times c, which in this case is -84, and that add to b, which in this case is -5. So we need to go through the multiples of -84. So again, we want it to be somewhere near the middle. But you could just go through all of them. We're going to have -1 and 84, 84 and -1, 2 and 42, 3, I don't think so, 4 and 21, we're getting closer, 5, no, 6, no, 7, yes, 8, no, and 9, no, 10, no. So I think this is our closest one. So we're trying to add two numbers to get to -5. So here we go. We add those two numbers together. We are getting -5. So as the numbers get bigger, they get trickier in what they are, but just take a minute, write them all out, play on your calculator. I do that in my head a little bit faster than most people, but just go through the numbers. So start with 1, then 2, 3 wasn't going to work, 4 does work, not 5, not 6, yes 7, not 8, not 9, not 10, and then I'm up to 11 and 12, so I know it's not going to be anything more than that. So just go your calculator, 84 divided by 2, 84 divided by 3, 84 divided by 4. Keep going until you find the numbers that you're looking for. So now I can just place them in because I don't have an a term anymore. I've got x plus 7, x minus 12. And we know from looking at our y equals x minus r, x minus s, that we're just looking at the opposite numbers. But we can write them out. X equals -7, x equals 12. Those are our two numbers. Now, those are our two numbers given a parabola like this. So which one makes sense? We've got two numbers. We got a -7 and a 12. Which one makes sense? Well, we're not going backwards from where we threw it. We're standing on, this is you, standing up there on the y-axis. You've thrown a rock. What are we throwing? A stone into the water. You haven't thrown it backwards. So we know that this one doesn't make sense because that's backwards. So x equals 12 has to make sense. First, we're going to check it to make sure I didn't screw up again. So going back to our original equation, So we're trying to get a 0 in here. And realize that that x and that minus are different. So I've just filled in the x with the 12. So the minus has to be in front of the bracket because the minus and the x are separate. So we need to make sure that that is outside the bracket so that it doesn't change our answer. What we want is negative 144. If that was inside the bracket, that would change it completely. 5 times 12 is 60 plus 84. And we end up with a good check equaling 0. So first we checked. Now we need to write a sentence that explains that we understand what 12 means. So what were we trying to find? How far does the stone travel horizontally before it hits the water? So the stone travels 12. What unit are we using? We're using meters. 12 meters horizontally before it hits the water. Make sure that you have a sentence showing that you understand what 12 means. All right, that's our first one. There's a textbook solution. There's them dividing out the 1. They didn't show how they found the 7 and the 12, so I want to make sure I had that in there. So we're rejecting the negative root. We're rejecting the negative root because it is impossible to have gone negative 7 meters. Come on, turn the page. And since x represents a distance, it cannot be negative, so we need to reject that negative 7. We checked, we got 0 on both sides, so the stone travels 12 meters horizontally before it hits the water. Good, got it. Number 3, dimensions of a rectangle. We love our rectangles. So a rectangle has a dimension, 3x plus 1, 2x plus or minus 5. So that is our length and our width. Now they're giving us an actual area in numbers. So now we can find what the dimensions are given our area. So area of a rectangle. Area equals length times width. We should know this one. And if it equals 1150, we are going to fill in our length and our width. Now, not as simple as it looks, because we are going to have to, we can't just say 3x minus 1 equals 0 or 3x minus 1 equals 1150. That's not going to find us the answer. So we have got to put this into standard form and then refactor it so that we can have something equaling 0. So I think I need to add in another slide for this one. Oh, and I forgot to save it twice. So we need to FOIL. We need to do first, outer, inner, last to get our standard form. So some people have been talking about how do I move between this form and standard form. This is how we do it. So our first, 3x times 2x, 6x squared. Our outers, 3x times negative 5, negative 15x. Inners, 1 times 2x plus 2x, and last 1 times negative 5. Now I can move over my 1150, making it negative. So it goes from positive 1150 to negative 1150. I want everything to be on the one side. Now I'm going to simplify. Minus 13x minus 1155. Now we can group. Oh, we are going to do it. All right, so now we need to find some factors of 1155. This is a tricky one. And like I said, start with your calculator, work your way up. What are two numbers that are going to multiply to 1155 and subtract to negative 13? Or add to negative 13. That's going to take you some time. So again, starting where you go, just keep trial and error, getting them bigger, getting them smaller, until you figure it out. So I'm going to go ahead with the answers. So I wouldn't give you one where the numbers are that complicated on a test, but you definitely need to be able to do them in the homework where you have time to sit and look at what they could be. So trial and error going up. What is 10? What is 20? What is 30? Am I getting closer or farther away from 13? So trial and error, keep it up. Now I'm going to group first two, second two. Out of my first two, I can pull out 6x. So I just end up with an x minus, and 90 divided by 6 is 15. Sorry, divided by 6, divided by 6, x. So 6x is what I'm dividing both of them by. That's what I'm factoring out. So it goes outside the brackets. Both of those terms get divided by 6x. We end up with just an x left, minus 15. Negative 77x minus 1155. What can I pull out of there? Well, I know that 1155 is divisible by 77 because that's how we got it, times 90. So that is a little bit of a cheat to get in there, or times 15, sorry. So again, trial and error. I know I want to have an x left over. Because I have an x here, I'm thinking I'm going to be able to pull out that 77. And I want it to be negative 15. So I take out my calculator, I go, all right, can I divide 1155 by 77? Yes, it works out. So I end up with it there. So that's some of the thought process that goes into it. I know I want to end up with x minus 15. I've got 77x. I'm probably going to divide by 77. So divide both of those terms by 77. Using my calculator, I can find that 1155 divided by 77 is 15. So now I've got two pumpkins. I've got 6x pumpkins. You've got 77 pumpkins. We put them together. They just stay the same. We don't change anything else in there. And then we have together, we have 6x plus 77 pumpkins. So now we still need to solve for x. Still need to figure out what that is. So we need to pull them apart again. This is the basics. Everything else that we're doing has been from past questions, except for this part at the end. So we've done this in other places. So we end up with an x equals 15. Or an x equals negative 77 over 6. Again, which one makes sense? Do we have a negative 77 over 6x? Let's look at how that's going to work out in our length. So 3x plus 1, 3 times negative 77 over 6 plus 1. Again, we can cross that out, make it a 1, cross this out, make it a 2. Negative 77 over 2 plus 2 over 2, anything over itself is a 1. We end up with negative 75 over 2 meters. Does that make sense to have a negative meter on a length? It does not. So we need to reject this one. Can't be real. It's getting late. I'm not even writing words properly. Can't be real because it is negative meters. Can't be right. So we know x has to equal 15. Let's check into our formula to see if we get there. So using the formula we created here, length times width equals area. 3 times 15 plus 1, all in brackets, times 2 times 15 minus 5. Does this equal 1,150? 3 times 15 is 45 plus 1. And 30 minus 5. So we end up with 46 times 25. And 46 times 25, if you put that in on your calculator, does equal 1150. So we've got our check right. We figured out which one can be wrong. All we need to do is write a sentence, and when you are working in your test, please write this out in more space. I'm just out of space on my slide, and I don't want to pull to a second slide. So please write this out neater. So what are the dimensions? So dimensions means length and width. The dimensions are 46 meters and 25 meters. So you could also write the length is 46 meters and the width is 25 meters, or the dimensions are 46 meters and 25 meters. That was the answer to the question, so that gets our box around it. That's our answer. All right, so here's the method going through from the textbook. Take a look at if that makes more sense to you. How to check. Key concepts for this chapter. If two factors have a product of 0, then one or both of the factors must equal 0. So if we've got A times B and they're equal to 0, then A equals 0, B equals 0, or both equal 0. A quadratic equation has degree 2 and has a single unknown. For example, x squared plus 2x minus 3 equals 0 is a quadratic equation. All right, so basically a quadratic equation has a 2 in it, has a squared. We knew that. Some quadratic equations can be solved by factoring. To solve a quadratic equation by factoring, first write the equation in the form ax squared plus bx plus c equals 0, and then factor the left-hand side. So in one of our examples, it wasn't quite in that formula yet. We needed to get it into this equation, and then we could factor it out again. Next, set each factors equal to 0 and solve for the unknown. So these are your steps if you want to come back and look at steps. Those are the two major things that are going on. So the example is x squared plus 2x equals 3. First, we need to get it into this form. Then we need to factor it. First, we want to get into that form. Then we want to factor. Then we want to set each to 0 and solve. Those are kind of the 4 steps. The solution to the quadratic equations are also known as the roots of the equation. So we're going to use the term roots. It means solve for x. Homework. Page 279, 1 to 4, ACE. So 1 ACE, 2 ACE, 3 ACE, 4 ACE, then 6 to 9. Good night.